The University of Kentucky has extensive facilities for nanoscale science and technology research, and we have facilities for all the major processes that you'd want to do in order to make nanoscale devices. And this is just a super experience for people to get some hands-on work in the lab. Then as a result, hopefully, that research is disseminated to the academic community.
All of us, we are working in different field, but going towards the same goal.
The Hastings Group basically are very heavily, they're very heavy in their operation of the more advanced lithography tools, the e-beam lithography tool in particular. So they probably utilize that tool 80% of the time it's utilized.
In particular, the research that our group is focused on is often viewed as nanomanufacturing. E-beam lithography is a means to turn out a number of nanoscale devices. Electron beam lithography is the process of taking a beam of electrons and focusing it down to a really small spot, sometimes even less than a nanometer, and then using that beam to write a pattern just like you or I would write a pattern with a pencil or a pen on a sheet of paper, but just at a much smaller scale. All of electronics, whether it's in communications, computing, data storage, whatever, depends on moving things to smaller scales so that things can operate faster and with higher density. Surface plasmon resonance is a really interesting phenomenon by which light propagates or clings to the surface of a metal. And usually we're interested in metals like gold or silver. Their properties are particularly good for this.
So far, most research on the SPR sensor and the widely used SPR sensors are just single mode sensors. But our group, we are working on the dual mode SPR sensor.
Basically, the sensor works by binding on the gold surface.
On the SPR sensing side, there are two students, the first of whom is Donnie Keithley, an undergraduate in electrical engineering. Currently,
right now, I guess my big focus is helping out with a wave-guided SPR sensor.
Another student, Jing Guo, is also working on surface plasmon resonance sensing.
Basic point of this sensor is we use the surface plasmon resonance wavelength to detect the surface change.
On the electron beam lithography side, our lead student is Yugu Yang.
I'm doing all the design, FPGA design on computer by using some simulation software.
Similarly, a postdoctoral associate in the lab, Chandan Samantare, is working on enhancing accuracy and precision in e-beam lithography.
We are doing some of the nano patterns and the nanoscales, which is the pillars of nanotechnology.
A lot of times we do have to make efforts to translate that research to the general public and to companies who might benefit from it. We recently had an article published as part of a PBS series on innovation, and there was an accompanying article on nanotechnology to try to walk people through what nanotechnology really is.
We have Engineering Day, which is an annual event.
And it's an opportunity for the community to come in and really see what engineers do, what engineering students are learning, and what's going on at the university.
We're in the process of applying for a National Science Foundation grant to allow us to develop a mobile source of nanotechnology education.
In the long run, we firmly believe that on the nanomanufacturing side, and specifically with regard to electron beam-based processing, that there's going to be a dramatic need for precision and accuracy in addition to being able to make small structures. On the sensing side, we really hope to move this technology out of the lab and into commercial applications.
I really want to make something useful to the others.
We want to take this technology and move it forward further into the real world.